All right, so now that we're back, we're going to be looking at different number examples, and we're going to decide where they fit in our organizer. So we have our organizer of rational numbers, and we have several categories, and then we have our organizer for irrational numbers, which has no subcategories. If a number is irrational, it's simply irrational. If a number is rational, it could just be rational, like the number 1/2 is just rational. But a number like 2 might fit into more than one category. And we're going to talk about that in a second. So, first number that we're going to look at is the number 0. And we talked about 0 as being kind of a unique number because it's a number that talks about nothing, the number of nothing, which is a little bit strange. So first thing that we have to talk about is 0. Is it rational or is it irrational? Can it be written as a ratio? Now, we already talked about the fact that it can. We can say 0 over 1 and make it into a ratio. 0 divided by 1 is 0. And so we know it can be written as a ratio, so it's definitely not irrational. Is it rational? Yes. Is it an integer? Yes. Because it fits here on our little almost like a virtual number line that goes from the negatives to the positive. 0 will be right there in the middle. So yes, it's an integer. Yes, it's a whole number. In fact, 0 is what makes the whole numbers unique because natural numbers did not include 0. So yes, it is involved it is a whole number. But no, it's not a natural number. So 0 we can describe as rational, a integer, and a whole number. You can write that in any way that you want. But if you were asked, what type of number is this, how would you categorize it? It is a rational, it is an integer, and it is also a whole number. Okay, next example. 2 over 1. Well, we don't have to think too hard about whether or not that is a rational number because it's already written as a ratio. So we know that it's going to be in this category. But then the question is, can 2 over 1 be in any of the other categories? This can seem like a trick question because in the integers, the whole numbers, the natural numbers, there are no fractions per se. However, 2 over 1 is just another way of saying 2. So is 2 in the other categories? Yes, it is. 2 is an integer, 2 is a whole number, and 2 is a natural number. So 2 over 1 would fall into all 4 categories, as rational, as an integer, as a whole number, and as a natural number. All right, 2 down. A few more to go. How about the square root of 4? Actually, let me take this down. First of all, we ask, is it rational or irrational? Now, many students fall into the trap of seeing the square root sign and thinking this must be an irrational number. However, some of you quick-witted among us are noticing already that the square root of 4 is really just 2, right? We know the square root of 4 is 2. So the answer to this question is the same as the answer to this question. These are the same number, just written different ways. So, this would fall into the category of rational. It's an integer, it is a whole number, and it is a natural number, just like 2 over 1, because it's the same number. Okay, here's another one. 3/4. Rational, because it's a ratio, but does it fit into any subcategory? It can fit in up here, but it doesn't have a whole quantity to it, or 3/4 by nature is not a whole. In all of the other categories, integers, whole numbers, natural numbers, they all require that the number be a whole of some kind. 3/4 by nature is not a whole. So we would say that 3/4 is rational, but that's it. We can't categorize it any further than that. It is a rational. All right. The square root of 7. This one, like the square root of 4, our initial reaction usually is to say irrational because it has a square root. And in this case, we would be correct because if you put that number into your calculator, I assure you it will not come out with anything very pretty. Not to down our irrational numbers, but they're not exactly the prettiest things. So square root of 7 is simply irrational. That's all you have to say. All right, 2 more. we have this 0.752983. Kind of and it keeps on going. Now, if there were no ellipses here, there were no dot, 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 and we had just this number, that number could be irrational. Actually, it is a rational number. It would require being 752,983 over a million, over 1 million. That would be the fraction that we'd have to make, kind of a large fraction, but it could be written as a fraction. But when I put this sort of continuation, and I'm not saying that it's repeating itself, I'm just saying it goes on and on and on, it doesn't have a pattern, this number becomes irrational because I can't write it as a ratio. There's no specific end and there's no repeated pattern. So this would fall into the irrational category. Similarly, but a little bit different, is this repeating, well, this, I should say, this continuing decimal that happens to also be repeating. So we have 0.333 repeating and so on. This number is associated with the ratio 1 over 3, right? If you say 1 divided by 3, you get 0.3 repeating. So this number, even though it's written and it kind of looks like, oh wow, this could be a busy number that just keeps going and going, it can be written as a ratio. So it falls into the rational category. It does not qualify as an integer, a whole, or a natural number, just like 3/4 didn't qualify as being part of those categories. But this does qualify as a rational number. So no, it is not an irrational, it is a rational. Those are our examples. We're going to take a quick break and then come back with talking about how to compare numbers.